Girih, also Girih sāzī or Girih chīnī, is an Islamic decorative art form used in architecture and handicrafts, consisting of geometric lines that form an interlaced strapwork. In Iranian architecture, gereh sāzī patterns were seen in banna'i brickwork, stucco, and mosaic faience work. Girih has been defined as geometric designs composed upon or generated from arrays of points from which construction lines radiate and at which they intersect. Straight-edged symmetric shapes are used in girih. Girih typically consists of a strapwork that forms 6, 8, 10, or 12 pointed stars separated by polygons and straps, and often they were drawn in an interlacing manner. Such patterns usually consist of a repeating unit cell with 2, 3, or 6-fold rotational symmetry that tiles the plane with no gaps. The three-dimensional equivalent of girih is called banna'i. It is used to decorate the underside of domes or squinches. History. The Girih style of ornamentation is thought to have been inspired by the Syrian Roman knotwork patterns dating back to the 2nd century AD. The predecessors of the Girih form were curvilinear interlaced strapwork with threefold rotational symmetry. The Umayyad Mosque, in Damascus, Syria has window screens made of interlacing undulating strapwork in the form of 6-pointed stars. The window grilles in Kirbeit al-Mafia in Jericho has interlaced tracery as well, but with curved lines. Carved stucco showing simple knotted strapwork at the Masjid-e Jami in Nain, Iran also is in the form of curved knotwork. Some of the earliest architectural examples of geometric patterns made of straight strap lines can be seen in the Arabata Mausoleum portal, village of Tim, near Samarkand, Uzbekistan, and in Rebit-i-Mahi, Iran. Illumination. The earliest form of girih on a book is seen in the frontispiece of a Quran manuscript from the year 1000, found in Baghdad. This Quran has an illuminated page with interlacing octagons and thuluth calligraphy. Woodwork. In woodwork, one of the earliest surviving example of Islamic geometric art is the 13th century minbar of the Ibn Tulun Mosque in Cairo. In woodwork, girih patterns can be created by two different methods. In one, a wooden grill with geometric shapes would be created first, then the holes would be left either as holes or filled with some material. This woodwork technique was popular during the Safavid period. Examples of it can be seen in various historic structures in Esfahan. Architecture. The term girih was used in Turkish as a polygonal strap pattern used in architecture as early as the late 15th century. Also in the late 15th century, girih patterns were compiled by artisans in pattern catalogues such as the Topkapi Scroll. While curvilinear precedents of girih were seen in the 10th century, fully developed girih patterns are not seen before the 11th century in Iran. It became a dominant design element in the 11th and 12th centuries, as for example, the carved stucco panels with interlaced girih seen in Karakan towers near Qazvin, Iran. Stylized plant decoration were sometimes coordinated with girih. After the Safavid period, the use of girih continued in the Seljuk and later the Ilkhanid period. In the 14th century, girih became a minor element in the decorative arts and was replaced by vegetal patterns during the Timurid era. Construction. The first girih patterns were made by copying a pattern template along a regular grid. The pattern was drawn with compass and straight edge. Today, artisans using traditional techniques typically use a pair of dividers to leave an incision mark on a paper sheet that has been left in the sun to become brittle. Straight lines are drawn with a pencil and an unmarked straight edge. Girih patterns made this way are like a two-dimensional crystal, tiling the plane with a unit cell. Because the tiling was done by translation or rotation operations, the unit cells had 2, 3, 4 or 6-fold rotational symmetry. Geary tiles. From around the year 1200, girih patterns were made with stars and polygon patterns having 5 and 10-fold rotational symmetry. Such figures can be drawn by compass and straight edge as well. However, by the 15th century some Girih patterns were not periodic anymore. Such patterns were constructed by the use of Geary tiles. These are a set of 5 tiles with lines drawn on them. When used to tile the plane with no gaps, the lines on the tiles form a Girih pattern. It is not yet known when Girih tiles were first used instead of compass and straight edge construction. It is considered likely that Girih tiles were used on some buildings built around 1200. Girih tiles. A Girih pattern made from Girih tiles. Detail from the Yesel Mosque made from the Girih pattern on the left. 2-level designs. The Girih patterns on the Derby Imam shrine built in 1453 at Isfahan had a much more complex pattern than previously seen. The details of the pattern indicate that Girih tiles, rather than compass and straight edge, were used for decorating the shrine. The patterns on this shrine appear aperiodic, that is, within the area on the wall where they are displayed. They do not form a regularly repeating pattern. Another characteristic of the patterns at the Derby Imam shrine is that the Girih patterns are drawn at 2 different scales. There is a pattern that is discernible when the building is viewed from a distance, and a smaller scale pattern that is part of the larger one that one sees when near the building. Although there is evidence that some ancient Girih tilings used a subdivision rule to draw a 2-level pattern, there are no known historic examples of subdivision rule can be repeated an infinite level of times. For example, the pattern used in spandrel of the Derby Imam shrine consists of only decagons and botis, while the subdivision rule uses these 2 shapes and also the elongated hexagon tile. Therefore, this design does not show self-similarity between level 1 and level 2. However, a tiling design containing decagons and that has self-similarity resulting from the repeated application of a subdivision rule results in a quasi-crystalline tiling. Aperiodicity. Aperiodic tiling of the plane is the regular repetition of a unit cell, without any gaps. Such tilings can be seen as a 2-dimensional crystal, and because of the crystallographic restriction theorem, the unit cell is restricted to a rotational symmetry of 2-fold, 3-fold, 4-fold, and 6-fold. For this reason, it is not possible to tile the plane periodically with figures having 5-fold rotational symmetry, such as a 5-pointed star or a decagon. Patterns with infinite perfect quasi-periodic translational order can have crystallographically forbidden rotational symmetries such as pentagonal or decagonal shapes. These shapes with 5-fold symmetry repeat periodically, although the space between them contain other shapes that do not have a periodic pattern. Such tilings are called quasi-crystalline tilings. One way to create quasi-periodic patterns is to create a Penrose tiling. Another way to create quasi-periodic patterns is by subdividing Girih tiles repeatedly into smaller Girih tiles using a subdivision rule. In the limit, the plane would be divided into Girih tiles that repeat with frequencies that are aperiodic. The use of such a subdivision rule would have been evidence that Islamic artisans of the 15th century were aware that Girih tiles can produce patterns that never exactly repeat themselves. However, all known Girih patterns made with Girih tiles show no more than a 2-level design. In fact, there would have been no practical need to have a Girih pattern that had more than 2 levels of design, because a 3rd level would have a scale either too large or too small to be perceived. It appears that medieval Islamic artisans were using a tool that had the potential of creating highly complex patterns, but they never realized it. As E. Makovaki argues, the artisans were satisfied by creating a large fundamental domain without being concerned with the mathematical notion of indefinitely expandable, quasi-periodic patterns. However, they understood and used to their advantage some of the local geometric properties of the quasi-crystalline patterns they constructed. The Topkapi Scroll. The Topkapi Scroll from the late 15th century documents that Geary tiles were used to create Girih patterns. The The drawings in this pattern book show the Geary lines superimposed with the tiles used to generate the Geary pattern. Panel from the Topkapi Scroll, showing Geary patterns at 2 different scales and Geary tiles to construct them. Reconstruction of the small-scale pattern in left panel, using small Geary tiles. Reconstruction of the large-scale pattern in left panel, using large Geary tiles. Gallery.